Hello folks, my name is Madhu. I work at Red Hat. This is a recording that we did for the OpenStack Summit. Here we'll be dealing with network virtualization support on OpenDaylight and how it interacts with OpenStack and Open vSwitch using OpenFlow and OSDB protocols to orchestrate the network for multi-tenant virtualization. Uh, we have multiple recordings that we did in the past for demonstrating the network virtualization concept, and this demonstration will concentrate more on a specific problem statement. Where, if you look at today's OpenStack, you'll see the resource guarantees are provided on the compute and storage using a mechanism called flavor, where the end user can decide a flavor they want to deploy their tenants on, and based on the flavor you will get appropriate compute and storage for every VM being deployed. Uh, but if you look at the network as a resource, there is no flavor support for that as of today, as of ISA's release in OpenStack. OpenDaylight being an open SDN controller, it has an intelligence not just on the overlay networking, but also provides a network awareness of the underlying network. So with that powerful combination of providing simplicity of overlay network and providing network virtualization, it can also guarantee resources on the underlay, and hence we can introduce a concept called a flavor concept for also the network layer and provide guaranteed resources on the underlying network as well. Uh, this is essentially what we are trying to demonstrate in this on this demo. And in order to do that, we have multiple applications be part of this demonstration, and I will take time to explain each component that makes this demo. Of course, the entire demo is based on OpenStack with network virtualization. Uh, we have recorded a lot of good videos on that. For basics, please refer to that. Uh, and we wrote the Flavors app, which is written as an application on OpenDaylight to provide resource guarantees for the tenant virtualization. It is nicely integrated both to OpenStack Neutron and also with the OpenDaylight SDN controller as well. So that's an interesting app to look for. Then we have this policy-based traffic steering, which is a very interesting application on top of OpenDaylight, which provides traffic steering capability based on various customer properties. For example, we can have a policy based on dollar cost of a given link, which can change during a time of the day, or it could be based on bandwidth latency or other SLAs that customer care offers to the end users. So that is an app that is developed on OpenDaylight. It's very interesting to see. Uh, then we demonstrate the various protocols that supported on OpenDaylight, like OpenFlow 1.3, 1.0, OSDB, so on and so forth. Uh, these are all like support multiple versions of the Southbound plugins. All these are controlled on OpenDaylight. And we also have Open REST APIs, which the controller exposes, OpenDaylight controller exposes. And there's a project called Dlex, which is a management solution, which uses these outbound APIs to provide a easy to use user interface. And you'll see that the Flavors app makes use of this Dlex UI for providing its services. And we also have a tool called Hyperglance, which provides a good data visualization solution, and it's a commercially available product which we'll demonstrate as well. Uh, Quickly go into a high-level picture. So here we are showcasing that OpenStack interacts with OpenDaylight, and OpenDaylight interact with the overlay edge boxes. As you can see here, these are the edge boxes on which these are the compute nodes on the OpenStack side, and the VMs are being launched on the by Nova. So the left side overlay tunnel indicates that, where OpenDaylight takes care of doing the overlay virtualization using the GRE or VXLAN or VLAN tunnels. While on the right side, you can see that OpenDaylight can also orchestrate the underlay fabric essentially. So we can see that we have the leaf boxes and spine boxes in which we can provide policies on this underlay based on the overlay requirements, SLA requirements, and hence we can provide a flavor kind of an application for the end users to make use of. So this is the very, very high level picture of what to expect in this demonstration. And we are going to demonstrate it based on a multi-tenant virtual network where tenant A is provisioned using GRE tunnels, where the topology is an isolated virtual topology, and the tenant B is based on a VXLAN based tunnel. And as you can see, these two are managed by OpenFlow and OBSDB, while the physical fabric which actually carries these virtual networks is controlled by OpenFlow, and we are going to showcase how it is done. This is a quite popular picture that we have to demonstrate the or end-to-end architecture piece. We have dealt in detail in other videos, so please refer to that. The demo recording itself is pretty simple, where we have the OpenDaylight controller and the OpenStack nodes. Rather, let's go here and yeah, this is the demo components that we have, which we covered as already. And let's go into this one. This is an interesting one. So this is the actual topology that we have today for the demonstration. It's made of 3 different networks. One is the management network, which is 192.168.58.x. We have 2 data networks, 56 and 57. So essentially, as you can see here, OpenStack compute node 1, which is also the OpenStack control node. The data path it uses is the 168.56x network, while the OpenStack compute node is in a different layer 3 subnet, which is 57x, and these two are separated out using an underlay fabric, and we are simulating the fabric using a tool called Mininet, which is again open usage based purely underlay solution, where you won't have we don't have tunnels or anything like that. We have just pure open flow, and we use OpenDaylight to control that as well. So the Mininet here is used purely to simulate a physical fabric. So it's pretty awesome there that way. And the end objective of this demo is to demonstrate that for tenant 1, where they have a silver flavor, where they want a better resource guarantee, then we'll orchestrate the traffic based on various traffic hints. We'll identify and then do a traffic steering on a given path. In this case, it takes we have L1 to S3 to L1 and L2 to go on and so forth, while another tenant which has a bronze flavor will take a different path as well, right? So this is exactly what we are going to demonstrate on this demo essentially, and to most of the demo will be on a terminal. So just to bring you guys up to speed, I will map these various components into the terminals so that it will be easy for us to digest the flow. So the OpenStack, the OpenDaylight controller that you see on the top is the terminal on the bottom right here. So this is the OpenDaylight controller, where now, as you can see here, this is one of my distribution that we took from hydrogen distribution, and this is the OpenDaylight controller that we have. And in order to run it, we can just do a run.sh with these parameters. Will run the controller, and the mininet is right here. So the left side is the mininet, as you can see here. This is the mininet, and we also have the VM here, using which we will actually start the mininet. So I have a script called the start mininet mini, and using that, this will start the mininet, and you'll start seeing the switches to control to the controller as well. Yeah, the controller is coming up here, and we have the OpenStack compute node. Compute 1 is the control node as well. So this is the OpenStack controller that we will be using. So if you want to do, you can do a stack.sh is going to start the stacking process, and the compute node 2 is the right side here. I can do a stack.s that is going to start stacking, and as things proceed, we can do a OBSBSCTL show on the mininet box, and you can see that there are four switches here: L1, L2, S3, and S4 here, and we have everything required is up and running, and the controller would have learned these switches and the underlay switches and also the overlay switches as well. The obvious instances running on the compute and control node of OpenStack. Now let's switch back to the user interfaces, where I have three user interface here. One is OpenDaylight, other one is for the Flavors app, other one is the OpenStack itself. So when you log into the OpenDaylight, you see that the OpenDaylight has actually learned all the switches here. So the leaf 1, leaf 2, spine 1, spine 2 are the underlay switches controlled by OpenFlow completely. And you can see that we have the control BRint and the control BR tunnel. These are two switches that is created on the OpenStack compute node, control node in this case. And you can see the right side, you can see that it's a compute BRint and compute BR tunnel. These are the switches that is created on the compute node. Here I renamed the switches for simplicity, and we can save the name so that we can refer it in the future as well. But if you look at the node IDs are like hexadecimal numbers, which is not human estimate one. That's why we have named it, which we can read and refer to easily. And you can see that there's a special IP address has been learned here, which is the 192.168.56.101, which is the tunnel data path endpoint address of the control node or compute one. So in DevStack, if you're running DevStack, the control node and compute node are kind of they run both in this case. And the compute 2 BR in tunnel has an endpoint of 192.168.57.101. As we explained before, we have two different they are running in two different subnets, and OpenDaylight controller will orchestrate the underlay to perform the required routing and takes care of traffic engineering as well. Now, as you can see, these are two different islands now. They are connected only by the underlay. But ideally, it'll be nice to show the actual tunnel established between these two control and compute node. The reason we don't see the tunnel here is because the tunnel is not established yet by the OpenDaylight controller, because the OpenDaylight controller is intelligent enough to wait to understand the presence of a host before creating the tunnels. Now let's actually start working on the backend to start launching VMs. Let's create some tenants. Let's call Pepsi and Coke tenant, and let's launch some VMs to see how things start spawning out now. Before we go there, let's also log into the other UIs. So this is a Deluxe UI on which we have an application called Flavor application right here. And this UI is pretty clean, where we can also get all the information about OpenStack networking from as viewed by the OpenDaylight controller. So OpenDaylight controller has learned these two networks, which is the public and private network, and it has learned few subnets and ports, which are essentially default OpenStack instances because we haven't created anything yet. Now let's actually drill deeper into the so OpenStack is here, which will log in, and once we create tenants, we'll log in here. Now let's switch back to the backend, and let's see what we can do here. Okay, now I have some shortcuts here which I use for creating tenants. So here I'm going to create tenant and create some users on that, and let's also print the this guy. So yeah, now I'm creating a tenant called Coke followed by Pepsi, and once the tenants are created, you will see that we are creating user called Coke user and Pepsi user, and we are going to just print it to see that if everything is created properly. And it's being created now. So you say if you look at the keystone tenant list, you see that a Coke tenant and a Pepsi tenant are created here, as you can see. Users are all created as well. Now when I switch back to my UI, now I'm logging in as Coke. All right, so now Coke is logged in and is in the Coke tenant. Now when I switch back to the network topology, so now as soon as I click on network topology, you'll see that only the public network has been created here. Uh, so yeah, so we touched upon the OpenDaylight, Deluxe UI, and OpenStack. Now let's go back to the backend again, and let's launch some networks here. So these are the networks. So I'm going to launch a Coke network. Here, as you can see here, the Coke is going to we are going to create a GRE network here, and then subnet of 210.10x, right? 1.10.24. So let's launch the network here. So we are actually creating the Coke GRE. The name is Coke GRE and it's a GRE network, and we also are creating a subnet for that. And we also can launch a VXLAN network instead of GRE. Since we support both VXLAN and GRE, for Pepsi, we want to create a VXLAN network here. So as you can see here, for the Pepsi tenant, we are creating a VXLAN network here, and we are also creating subnets for that particular VXLAN network. So we have launched the network. Tunnel won't be created yet, but as you can see here, a Coke GRE network has been created on the OpenStack UI, and the DLX also, when you do a DLX network create, you see that the DLX also learned that, you know what, hey, network has been created, and as I was explaining, the DLX UI is an OpenDaylight UI, and it gets information from the OpenDaylight's backend code. So the OpenDaylight backend is actually received this the information about GRE and VXLAN network created, and that's exactly what is being displayed here on the DLX UI as well. So the flavor application is actually built on top of Deluxe project, and this Deluxe project's fork is using again OpenStack Horizon UI. For that's why if you look at the UI, it looks similar to the Horizon interface. And now the flavors application here is as we have a concept of flavors, class, and policy, and let's take a look at what each one does. Uh, First, before you create flavors, you have to create a class. So here, if you look at the class, let's create a class here, and let's give a class name. Let's call it now bronze. So now we are going to talking about bronze class of service, and here this is where we tie in with the um, application called an application-based property-based forwarding application running in OpenDaylight. And now we are going to use a simple application policy called the shortest path first policy. So if you look at this, one of the property names called the hop count based shortest path. So essentially what this means is if somebody wants a bronze class of service, then they will get a hop count based shortest path algorithm will be used. So let's create this class. The class has been created, and let's also create one more class here. Let's call it a silver class. So now it's a silver policy, and let's take the application property as number now, which is a very generic number policy, and you can start imagining this as a dollar cost or time of the day. A user can define these properties on the OpenDaylight controller. That's beyond the demo's purpose, so I'm not showcasing the how to create user-based policies as well. So now we are creating one more class called the silver class, and the number we are using the weighted least cost path as the class. So now we created two classes. Now let's go to the flavor. Now we're going to create a flavor for this one. So we can create a flavor, and let's call it again now bronze flavor, which is similar to the bronze SLA, and it's for bronze, it's just the bronze class. And let's create another flavor here called the silver flavor and silver SLA and the class. So the idea of having flavors and classes is that we can use the same class on multiple flavors, and you can use multiple flavors for individual tenants as well. So now we created two flavors, and if you go to the policy, you can create a policy here to state which tenant ID and which flavor you want to apply to. And this is where you need to go back to your OpenStack and get the tenant ID of the OpenStack. In this case, for the Coke, we have a tenant ID, user tenant ID, and Coke, let's apply a bronze policy. And let's go to the Pepsi. For Pepsi, let's give another silver policy here. Yeah, silver policy. Right. So with this, what we have done is we have configured the flavors application in combination with the policies, with the class of service policies. And once you tie these two up, when we actually create the tunnels, the tunnels will be appropriately applied on the underlay, and appropriate policies will be applied on that. Now let's go to the topology on the Coke, and let's launch some instances here. Now let's launch say test VMs, and let's launch two instances of it, and let's launch a specific image, so CDOS image, and we want to launch them on Coke GRE network. Do a launch, and now as you can see, the VMs are being launched on the Coke GRE network. And soon enough you will see that then once the VM is being launched completely, you'll start seeing that the tunnel is being established on the OpenDaylight UI. As you can see here, a tunnel is being formed between the BR tunnels of the control node and the compute node, and now any VM that is launched already on the BR now will be carrying over the tunnel. Now let's launch the VM instances for the Pepsi tenant. So let's sign off from the UI and log in as Pepsi. Now you'll see that in Pepsi you'll have a separate tenant for the VXLAN tenant which we created for Pepsi. Now let's launch the VM instances on the Pepsi tenant. Let's call this test again for Pepsi guys. Let's launch two VMs, and let's boot from an image, and let's choose a VXLAN terminal now. So once it's launched, it's very similar to the GR use case where it's going to launch the VM, and once the VMs are launched, you will see another tenant and another tunnel being created by OpenDaylight on the OpenStack network over the physical fabric, and this time it will be an VXLAN tunnel because of the request that we originally had for Pepsi tenant to create a VXLAN network. Alright, seems to be it's launched. Let's look at it now. Alright, now as you can see, this one more tunnel is being established, and that is the VXLAN tunnel. So, well, VM is launched. Let's open the console and see. Alright, let's do a zeros. Alright, we'll do a config. And you can see that the IP address has been assigned. It's 10.2.10.2.2. You can do a ping to the neighbor 2.3. And as you can see here, this ping is not going through because the IP address could be different. There you go. Okay, IP address is 1.4. That's why. So you can see that this ping is actually going over the VXLAN tunnel across the network and reaching the neighboring compute node, and then getting delivered to the appropriate VM, and the ping succeeds here. Right now, if you want to look at the actual traffic it is taking, which underlay path, the fabric path it takes, now we have to switch back to the. Let's go back to a tool that we have called the Postman tool. Here it will display all the roles being programmed, what are the flows being taken on the underlay. Now I execute this rule. As you can see here, there are two rules here, which as you can look at this is the bronze. This is the bronze policy being programmed between the two tunnel endpoints, 57 and 56, and we have the silver policy here. And this policy is completely applied on the underlay fabric. That's why you can see that the switches being taken are 0, 2, 2. If you look at the switches taking the the from 2 to 1, the leaf 2 to leaf 1 via the spine 3, and these are the port numbers. And for the silver policy, you can see it taking a different path altogether. It's from 1 to 2, which is like the same. 2 to 1 or 1 to 2 is the same reverse path. I mean, the path is the same, just that it's taking a different spine here because of the policies that we applied. This is the northbound API that we get back. But if you switch back to the an application called Hyperglance, Hyperglance is a UI that is built on top of the northbound APIs exposed by OpenDaylight. And as you can see, the northbound API that we just saw on the Postman, which gives out the information in JSON format, we can use the Hyperglance UI for extracting the information from the outbound API and also real-time data like the actual packet traffic being forwarded and so on and so forth. So here, as you can see, here we are showcasing only the underlay. We can also, if you want to look at the overlay, we can have a different cluster UI. In this case, this is the overlay information, and I clearly split out only the underlay information for us to concentrate on. And the nodes that you can show here, these are the tunnel endpoints which the underlay looks at, because underlay has no idea about how a tenant is being created, because overlay takes care of all the tenant isolation. So the tunnel endpoints are the endpoints for the underlay, and the OpenDaylight's flavor application took care of automatically programming the underlay policies to take different traffic engineering path for various on the filter UI, you can click on the bronze. So the bronze part, as you can see here, the bronze is taking from leaf 1 to leaf 2, taking a spine path, while for the silver, it takes the spine 2. This is because of the policy that we programmed to state that bronze wants shortest path, while the silver wants the least cost path. Uh, so having the bronze path as a high cost because of the way we have programmed the cost on the links, so it takes a different path altogether. Essentially, this demo concludes where OpenDaylight has the visibility of both the overlay, which is the tunnel established by OpenStack, and the OpenDaylight OSDB project, which establishes the tunnels. Also, since it has the visibility on the underlay, it can also do traffic engineering for the traffic that is going above and above the overlay, and to showcase that OpenDaylight has more things to offer on top of the overlay network. So that essentially concludes the demo. Thank you. Good videos on that. For basics, please refer to that. Uh, and we wrote the Flavors app, which is written as an application on OpenDaylight to provide resource guarantees for the tenant virtualization. It is nicely integrated both to OpenStack Neutron and also with the OpenDaylight SDN controller as well. So that's an interesting app to look for. Then we have this policy-based traffic steering, which is a very interesting application on top of OpenDaylight. Network as a resource, there is no flavor support for that as of today, as of ISAO's release in OpenStack. OpenDaylight being an open SDN controller, it has an intelligence not just on the overlay networking, but also provides a network awareness of the underlying network. So with that powerful combination of providing simplicity of overlay network and providing network virtualization, it can also guarantee resources on the underlay, and hence we can introduce a concept called a flavor concept for also the network layer and provide guaranteed resources on the underlying network as well. This is essentially what we are trying to demonstrate in this on this demo. And in order to do that, we have multiple applications be part of this demonstration, and I will take time to explain each component that makes this demo. Of course, the entire demo is based on OpenStack with network virtualization. we have recorded a lot of in the past for the for demonstrating the virtualization concept, and this demonstration will concentrate more on a specific problem statement where if you look at today's OpenStack, you'll see the resource guarantees are provided on the compute and storage using a mechanism called flavor, where the end user can decide a flavor they want to deploy their tenants on, and based on the flavor, you'll get appropriate compute and storage for every VM being deployed. Uh, but if you look at the hello folks, my name is Madhu. I work at Red Hat. This is a recording that we did for the OpenStack Summit. Here we'll be dealing with network virtualization support on OpenDaylight and how it interacts with OpenStack and Open vSwitch using OpenFlow and OSDB protocols to orchestrate the network for multi-tenant virtualization. Uh, we have multiple recordings that we did